Hi, I'm Chek from the Singapore Institute of Technology, and this is one of the videos I made for an introductory course on developing immersive applications. At the end of this video, I hope that you will be able to first describe common tools from a technical perspective for developing immersive applications, and two, to make informed decisions on choosing the right tools for your own projects and unique situations. In this video, I will first provide an overview, including appreciating some sample code, of the common tools for developing immersive applications. Using these representative tools, secondly, I will then go through some key factors in considering what tools to choose across different project and development environments. For example, factors like how accessible your end product needs to be and the costs of development. I will then, 3, provide our own justifications for what factors resulted in our own choice of using BabylonJS to develop WebXR apps for students in our introductory course, which this video is part of. When we talk about developing immersive applications in a broad sense, the kinds of tools are almost limitless. From using spreadsheets and documenting tools for budgeting and planning, to project or code management tools for coordinating the implementation and timelines across the team, to 3D authoring tools for creating art and assets, to implementation frameworks that help you deal with the lower levels of code so that you can focus on the more interesting components that actually deliver immersion characteristics. In this video, I will actually focus on the last kind of tool, which we will call development tools or dev tools here. However, I do believe that all the general purpose tools like GitHub for version control, VS Code for your IDE, or even Jira for Scrum management are all essential to the success of any immersive application development, right? For the discussion in this video, however, we will focus on the tools that are unique to helping us focus on building the immersive parts of the application. Let's dive into all the common dev tools now. First, if you have developed any kind of interactive application, it's easy to guess what is the first tool I will introduce here. Yes, Unity. In particular, if you have been developing mobile games, simulations, and other interactive apps, Unity needs very little introduction. Unity has a strong foothold in game development and is behind many popular games you may have played, including classic hit mobile games like Temple Run and Monument Valley, as well as AAA desktop games like Assassin's Creed Origins and an installment of The Legend of Zelda. Unity is made by the company Unity Software. As a New York Stock Exchange listed company, Unity, as its core product, is definitely aimed at making profits for the company. Being a public company also means that it has tons of cash to pour into developing the Unity tool professionally, which is why Unity looks extremely professional if you have used it, as well as very well polished, packed with loads of features and all sorts of development needs way beyond our narrow topic of interest here in terms of developing immersive applications. Unity has a visual editor for creating and modifying game objects using a component-based architecture. And each component can be driven by C# scripts in order to provide for custom behaviors and interactions. Unity also includes many built-in engines for modern rendering techniques, physics, and audio, etc., making it easy to create high-quality simulations and games. In terms of deployment, it covers almost any common platform that we see out there. For example, the various desktop operating system environments, Android, iOS, console platforms, and the web. To develop immersive applications, Unity has made project templates that devs can choose from when creating a new project in Unity. For example, AR and VR templates. These templates set up the necessary components and settings typical for AR and VR applications. After that, you can use the plethora of features within the Unity interface, coupled with some scripting in C# to bring your application to life. In the debugging view, when you click on the play button to test your app, you can also use the mouse and keyboard to simulate inputs for your intended device, or even connect common XR headsets to test it in the real thing. After you're done, you can also use the publishing workflow to build for your targeted platform. Unity deals with most of the connective tissues required to publish your app for real. But as usual, there are many nitty-gritty details that may prop up and require various amounts of tweaking for different platforms. Now for some fun, let's use ChatGPT to help us look at some starter code. Here you can see the typical structure of a C# script in Unity that implements some custom behavior related to a VR controller component, which you can attach to a game object in Unity. In this case, the code helps to move another target game object in correspondence with how your VR controller moves when the trigger button is pressed. I'd imagine this implements a grab and move interaction. Okay, hold on. I go and get a controller. No controllers here. Okay, continue. Of course, there is a lot of missing code to connect the dots, like how the controller actually receives sensor information from the physical controller. If you're interested in detailed tutorials on learning how to do all the fun things in Unity, you can of course turn to the rest of YouTube for the slew of tutorial content on Unity, even specific to immersive applications. Next, Unreal Engine. Unreal Engine is a similar product to Unity in that it is a massive feature-heavy software for creating real-time 3D applications. But it facilitates this development in different ways through their vastly different interfaces and features. Just like Unity, Unreal also drives many famous game titles, including the classic Unreal Tournament series, and perhaps it is most recently famous for the massively popular Fortnite game. Unreal is made by Epic Games, and although it is a private company unlike the listed Unity software company, Epic Games is still a huge MNC flushed with cash. For example, back in 2013, Tencent funded Epic Games with over $300 million for a stake in the company. And Epic Games certainly has shareholders to please. Unsurprisingly, Unreal Engine, one of Epic's bread and butter, is very much an important source of revenue for Epic Games. Again, similar to Unity, Unreal Engine has a sleek UI for component-based configuration of game objects and even includes a visual scripting language called Blueprints that enable a low-code solution for developers. However, for the coders out there, Unreal also allows developers to use one of the most hardcore of high-level programming languages, C++, to create highly custom mechanics and behaviors for your applications. Okay, now let's see what ChatGPT has in store for us with regards to Unreal code examples. Here we can see a new actor concrete class created, which represents an entire Unreal game object, being created purely in C++. This example is similar to the Unity one, in which we are setting up a game object to track what the VR head-mounted device does. When professionals are looking to build high-quality content with large teams, Unity and Unreal seem to be their go-to tools. However, generally I find that amongst the professionals I've spoken to, there is a clear preference for Unreal when really high-quality graphics is desired. Go figure. Next up, we have a tool that is entirely different from the previous two tools that we have spoken about. A-Frame is a web-based tool primarily provided as a JavaScript library. It is designed to be a highly accessible tool for new VR developers with some programming foundations. At the same time, it is highly extensible to allow experienced devs to create highly complex VR experiences as well. Note that applications developed by A-Frame can only exist on the web, which has the usual obvious pros and cons. The biggest con is perhaps the level of immersion from a systems point of view that is limited by what web technologies can provide, and in many ways limited by the browser developers as well. However, that is slowly improving as we move from WebGL to WebGPU, which, without delving into the rabbit hole of advanced rendering topics, simply means that we get more and more direct access to hardware right from your browser. Relatedly, the number of differences between each of the popular browsers is also something you might need to contend with, although open standards like WebXR do resolve that to a limited extent. Latest versions of A-Frame conforms to WebXR standards already. If you are able to navigate the cons of using a web-based tool, which you should be able to with the right motivations, the pros of a web-based tool like A-Frame are really tremendous for both your own app and the XR community, broadly speaking. This is because anyone with access to a common browser will be able to experience the XR content and interactions that you have created. Those with XR-specific devices like head-mounted displays like the Oculus Quest or the Meta Quest can experience the more immersive interactions with the dedicated hardware, whilst those with a desktop only can have a gracefully degraded immersion from the very same web implementation that you have done. This is huge for accessibility, and what is an app without users being able to access it, right? So notable mentions that have developed web-based VR experiences using A-Frame include the Mars 2030 simulation supported by NASA, as well as the web VR version of the 3D authoring tool Sketchfab. So A-Frame is an open source project by Mozilla, the same guys who are famous for the Firefox browser. Being entirely open source means it is the most accessible kind of tool for devs, and you can also view and change anything to suit your needs, which makes it really good for learning and also for us researchers who need to meddle with a lot of stuff. However, do note that currently none of the core maintainers that I can see from the GitHub repo are from Mozilla, as it appears that they may have moved on to other things perhaps. Notice that the latest release is quite some time ago and support does seem to be slightly waning. Well, don't get me wrong, A-Frame is a fantastic project and it has a really well-designed architecture and usable API design. We even used it for our own landing page for the Center for Immersification here. My Twitter feed also often sprouts up with new, cool A-Frame based prototyping experiences. However, do be warned in terms of the activeness of the community and support when you run into problems. Alright, hold on a second. I think you may be totally misinformed. Did you realize, or is it me? Okay, let's just say it's you. Did you realize that A-Frame just had a new release? Okay, let us just have a look at it. Let's go to A-Frame GitHub's page. Oh wow, indeed. It released v1.4 exactly after we decided to make this video. Of course, I'm not trying to claim any credit here. This is about 1 year after the last release. Pretty cool. So perhaps we should relook into A-Frame after all. Okay, now let's talk to Mr. or Miss ChatGPT again for starting development needs. You can see how simple this piece of code is, and it can be ran with simply a browser. Hey, wait, isn't this just HTML code? Didn't I say that it was a JavaScript library? Well, yes, it is a JS library. As you can see, it imported all of the A-Frame API in that single line with a copy of that release version hosted on the cloud. What's happening here is that the library basically created custom HTML tags that you can use in your code. Wait, hold on again. So what's HTML? If HTML is new to you, which is a perfectly fine thing, nobody knows every single language out there. But if HTML is new to you, perhaps you can continue the conversation with Miss or Mr. ChatGPT here. Actually, with regards to that, if I talk about something that you are unsure or have no clue about, I trust that you are able to make the necessary effort to research further, whether ChatGPT or not. Okay, now back to the sample code. You are able to create a new 3D scene with the HTML tag aScene, and also create instances of pre-made game objects with other tags. Think about prefabs in Unity. In fact, you can code up new components in JavaScript with your own custom tags and add these components into the game objects in the same manner here. I really applaud this simple declarative style of programming that is really intuitive. Let's move on to the next tool, BabylonJS. BabylonJS is another tool in the form of a JavaScript library. On top of that, BabylonJS has loads of supporting web tools like the Playground, which is a place to quickly test run your code, like a dedicated CodePen or glitch kind of an environment, and the Inspector, which is like a scaled-down Unity-style editor interface. Actually, A-Frame, the last JS library we covered, also has this Inspector thing, but the one in BabylonJS just looks more advanced. Speaking of looking more advanced, it appears that the rendering and physics engines of BabylonJS also utilize more state-of-the-art techniques and target performance more. Most importantly, I think, BabylonJS prides itself in its large and active community that is well connected to other open source web initiatives like React and Angular. It even has a branch that is looking at integrating with React Native to allow your code to publish natively to mobile platforms. In terms of the web, it fully supports WebXR. Okay, since we mentioned WebXR twice now, here's a bit more info about what it is. In general, WebXR refers to a set of open APIs that aim to standardize the way XR apps are created on the web. It originally started with the WebXR device API, but has since worked on a number of other open APIs, including the WebXR Gamepad API and the WebXR AR API. A greater adoption of common standards will go a long way in moving the industry forward. Think about the role of OpenGL in graphical programming. A great place to look at everything WebXR related is the page immersiveweb.dev, where you will find a comprehensive list of tools and guides to create WebXR apps. It is also interesting that the Immersive Web Working Group, the standards committee that drives WebXR, is made up of co-chairs from Apple, Microsoft, and Google. things certainly feels to be going the right direction here. Other than the large community of contributors and users, the maintainers of BabylonJS look like some very active people, primarily from Microsoft or with strong ties to Microsoft. Okay, now let's talk to our friend for some code advice again. We see that this is very different from A-frame, in which we are writing code that looks very much like a typical imperative style of programming. For example, you'll find this familiar if you come from the C++ camp. Most of BabylonJS implementation is done in JS files with this style of code. Note also that TypeScript or TS is the de facto language rather than pure vanilla JS. TS is simply the strongly or stronger typed version of the loose JS language. Again, if you come from the C++ camp, you may appreciate this more. We will have a dedicated tutorial on this soon, but no promises that we can be better than Mr. or Miss ChatGPT. So the tools discussed thus far all depend on an established foundation framework layer of code that we can use to build immersive applications while maintaining a good amount of expressiveness to convert our designs into implementation. Other tools that now I will quickly touch on are examples that lie towards the more extremes of developer preferences. On one end of the spectrum are tools that make you go as native as possible, for example with C++, whereas on the other end of the spectrum refers to tools that allow you to go as low code as possible, or even a no code solution. On the native high expressivity spectrum, we have the OpenXR SDK, which is primarily a C++ library. OpenXR is more than just a C++ library, however. It is also an open standards initiative to have device vendors align to a single API for the industry. OpenXR is managed by the large Kronos group, which also manages other large famous open source API standards across the industry, including OpenGL and Vulkan. You can think of OpenXR as the native development version of what WebXR is trying to do for the web. In fact, OpenXR aims to be the underlying implementation for WebXR moving forwards. As expected, there is a lot more effort to create an application using this purer form of development approach. From coding in C++, compiling it into a platform-specific library, and then using the library in platform-specific tools to deploy it in that environment of choice. It really is a bit of a chore. Okay, ChatGPT time. As you can see, this code simply shows a single frame without doing anything really meaningful for XR. And in general, it takes a lot more code and effort to grasp the intricacies of C++ to decently implement every small aspect of your implementation. After compiling the XR code as a library, you then need to figure out how to build the actual app components in your platform. It may still be C++ if you are distributing it like as an Linux app, but more often than not, you are likely going to combine this with other dev tools like using Swift in Xcode to package it for Mac OS or iOS, or Kotlin in Android Studio to distribute it for Android phones or the Meta Quest. Then you will need to figure out how these components in your platform can talk to the library that you compiled in order to call the XR methods. For example, in Android, you may have to work with the NDK or Native Development Kit side of things to talk to C++ code. So usually we only go this route if we need to implement some unique novel features that require ultra custom code close to the metal on the targeted platform. On the other end of the spectrum, we have code spaces, which is designed to be a really low barrier to entry even for users with zero programming experience, including supposedly for kids. Like many other low to no code platforms, CodeSpaces is meant to be a fun entry point for students to learn about application design and programming in the context of XR applications. This of course means that the variety of applications is greatly limited by the features that the CodeSpaces provides, and if you are building something for an actual business use case, you'd be lucky if all your requirements fall within the walled garden of features. That being said, I've yet to try this platform meaningfully, and there is an option to attach custom scripts written in JavaScript, so I reserve my judgment. Okay, let's see what ChatGPT has to say about CodeSpaces. As you can see, the instructions look really basic and does not say anything about writing code. At SIT, we do have colleagues from the Center of Digital Enablement who use CodeSpaces to successfully introduce, in a short course, people from all backgrounds to learn and appreciate the key components of what makes an immersive application. I believe that is a perfect use case for a tool like CodeSpaces. So we looked at a variety of common tools developers use to create immersive applications. There are of course a lot more other tools that we have no time to talk about in this video, but the list of tools here should provide a representative sample of vastly different categories of tools. So what are some key considerations when choosing specific tools to use or to learn? Ideally, the top consideration will be the requirements of specific projects or use cases. Sadly, if you use this requirement-centric approach to choosing your tools, then you sometimes have to forego your personal inclinations to use the tools that matches the intended immersive experiences better. For example, if you knew your client's users will definitely have MetaQuest Pros and that they will use it in medical training environments for real doctors, Unreal Engine may be the best choice. However, if you're building an application to crowdsource camera footage through an AR game, then you may want to have as many users as possible access the app. So BabylonJS may be the best bet here. So beyond the requirements of specific projects, there are also several non-functional considerations as well, which includes, firstly, the cost of using the tools, which is self-explanatory. For example, open source tools cost nothing while you need to redefine lines for proprietary ones. 2. Stability of the tools. It goes without saying that you would not want to pull your hair out every time to try and solve bugs inherent to the tools. 3. Customizability and extensibility. What options do you have to create novel features that make your app stand out from the crowd may be an important consideration. 4. Community and support. For open source tools, we'd often see how active is the community, and for proprietary tools, we want to see how responsive the support teams are. 5. Learning opportunities. This is not really a common consideration in the industry when it comes to choosing what tools to use, but I feel it is important for a relatively new industry like this. Basically, you need to ask whether the tool aligns with your learning objectives at the developer stage you are at. Is the tool opaque or transparent when it comes to implementing certain features you are interested in? Now, let me demonstrate our decision-making process for our own choice of tool for the introductory course that this video is part of, based on the factors that we have just mentioned. So for the students in our course and for the remaining videos in this series, whenever we have to demonstrate implementation, we will be building a WebXR app using primarily BabylonJS. And here are our reasons. So we are not advocates for BabylonJS or WebXR for that matter, and we are certainly not part of the steering committees of either. We chose to focus on BabylonJS to build WebXR apps primarily due to the fact that we want to facilitate learning to occur in the best manner possible, at least from our perspectives. That is aligned with the applied learning objectives of the broader introductory course at hand. So first reason, accessibility. It is like a big precursor to adoption. And getting more users to access the content that you make will get more eyes and hands on your product, which will provide you more feedback and improve your product continuously. Moreover, with the concept of metaverses, it is increasingly important to enable participation across boundaries of specific platforms and devices in a single persistent application environment. In the course, we hope students can play with each other's implementations easily and give each other feedback more often, whether they have the dedicated XR device or not. Second reason, BabylonJS is currently well supported by an active, large-ish community. If you look at the GitHub repository, there are frequent updates and conversations occurring all the time. For example, it is already starting to support the latest web GPU APIs that can take advantage of more modern GPU hardware, like supporting compute shaders. For students in this course, there is a higher chance that the technical skills they pick up here will serve them some purpose in their future endeavors. So third reason, using the WebXR set of APIs provides some longevity to the prototypes that you build. As again, there is a strong industry-driven open standards community to drive standardization, which makes it easier for you to transfer your knowledge more seamlessly when you need to utilize other WebXR-ready tools and devices. This also makes it easier for you to collaborate with others who are already building with WebXR. This means improved accessibility to developers on top of the improved accessibility to users as the completed app is web-based. Fourth reason, using BabylonJS allows you to appreciate the technical details and considerations when applying the knowledge of creating immersive applications to actual components in implementation. This is in contrast to using more opaque tools like CoSpaces, or even some Unity plugins like the XR Interaction Toolkit, for example. Having a more nuanced feel for the technical considerations will help in designing better and potentially more unique immersive experiences. Fifth, and the last reason, is that the hands-on assignment for the course is actually related to contributing towards an actual research prototype, which is called XR Author. So this provides students in the course with an applied learning experience to be part of a broader real research prototype development. As a closing note, what I have described is just a starting point for you to do your own research, or what financial people like to say, DYOR, to figure out the right tools for your own unique project and situation. Okay, that's all I have for this video. See you in the next one.